All right, let's get right into it. Picture this. You've been hitting the books for months, prepping for your Cambridge AS and A-level biology exams. You finally sit down in the exam hall, turn the page, and there it is, a question asking you to calculate the magnification and actual size of a specimen. Seems like pretty basic math, right? Well, here's the high-stakes reality. Mastering this single specific topic is an absolute non-negotiable necessity for your success in Biology 9700. Today, we're going to break down exactly why ordinary, textbook-level revision just doesn't cut it, and how we can systematically lock down every single mark.
Now, what's really fascinating and maybe a little bit terrifying is this massive number, 15%. That is approximately how much of the total marks in Paper 2 rely directly on you mastering these precise calculation questions. To put that into perspective, that is a massive chunk of your grade boundary just sitting right there on the table, waiting to be claimed. This isn't just some fringe topic you can gloss over. It is literally the core of your practical exam strategy.
And this example right here brilliantly illustrates the exact devastating mistake that haunts exam halls every single year. A student is under immense pressure, they do the math perfectly, and they write down actual size equals 0.05. And you know what happens? Boom, a flat zero. Why? Because they calculated the number perfectly, but they completely forgot to include the unit of measurement. It is such a tiny oversight, but it instantly crashes your grade before you've even had a chance to show the examiner what you actually know.
Section 1, the examiner's warnings. Let's peek behind the curtain and look directly at what the principal examiners, the people actually grading your papers, are saying about why genuinely smart students constantly drop points on these calculations.
So, it all basically boils down to these top 3 lethal errors, pulled straight from the Cambridge Principal Examiner reports. Number 1, forgetting to include units entirely, exactly like that heartbreak we just talked about. Number 2, forgetting to double-check your unit conversions and key terminology before you start crunching the numbers. And number 3, giving answers that just aren't specific to the biological context of the question. You see, examiners aren't actually out to trick you, they're testing your precision. If you can just avoid these 3 common traps, you are already way ahead of the curve.
But okay, let's be real for a second. What happens if you get in there and you just completely blank on the math? Well, here is a critical exam lifeline. Method marks can absolutely save you. We call this the method mark strategy. In these exams, your logical process actually earns you points. If you clearly map out your working on the page, write down the formula you're using, and show your conversion steps, examiners can award you method marks, even if you completely fumble the final calculator work and your final answer is wrong. It's all about process over perfection. That's your ultimate safety net.
Section 2, the Magnification Master Framework. So, how do we actually guarantee we get those method marks? We need a systematic approach that examiners desperately want to see so they can confidently award you those crucial points. Here is the exact step-by-step logic that basically bulletproofs your answers. Step 1. Deconstruct the given information. What are you actually looking at? What are your starting units? Step 2. Solve systematically. Actually write out your exact formula and show every single step of your math. Don't skip anything in your head. And step 3, which so many people skip, evaluate for reasonableness. Just stop and think about it for a second. If you calculate that a human red blood cell is 3 meters wide, well, something went horribly wrong. Leaving this really clear trail of evidence-based reasoning guarantees you capture every single available point. But hold on a second. What is the hidden examiner clue that changes the final answer completely? In just a moment, we're going to uncover the precise clue that shifts an answer from being just totally average to top band. But first, you're going to need a foundational tool that makes that hidden clue absolutely obvious the second you look at it. And that tool is a super simple but brilliant memory hack. You need to lock the core formula into your brain so you never freeze up under pressure. We're going to create a mnemonic using the first letters of the key terms, I, A, and M. Image size, actual size, and magnification. I am. The I is always sitting right on top of the equation triangle. So image equals actual times magnification. Get this I am concept locked in, and you will literally never mix up those foundational components, no matter how intense the exam gets.
Section 3, interactive exam challenge. All right, time to actually put this into practice. Let's actively apply our master framework to a Cambridge-style past paper example right now.
Let's look closely at some data. We're given an image size of 40 millimeters. We have a magnification of times 400. But the actual size, which they are specifically asking for in micrometers, is left completely blank. I want you to pause this explainer for a second.
Try to spot the hidden unit conversion trap in this data and systematically predict the correct actual size. Go ahead, give it a shot.
Okay, let's see how you did. This setup brilliantly illustrates the absolute difference between losing and winning. A flawed answer looks something like 0.1. The student just quickly divided 40 by 400 in their head. No unit conversion, no working shown, that's 0 marks. But a top band answer? That looks like 100 micrometers. The top band student explicitly showed their working. They converted 40 millimeters into 40,000 micrometers first, and then clearly divided it by 400. That explicit written out unit conversion? That was the hidden examiner clue. By visually mapping out the systematic working and clearly stating the units, they secure all the marks.
Section 4. Securing top band marks. Now that you've actually seen it in action, let's build that final layer of exam strategy so you can consistently perform at this highest level, even when they throw completely unfamiliar biological specimens at you on test day.
This right here is the standardized procedural sequence that top-performing students use to completely bulletproof their answers against careless, silly errors. Think of it as your ultimate mental checklist. Identify the key elements in the question. Apply the relevant principles, like our I am formula. Execute your analysis with super clear step-by-step working. Verify your results to make sure they're actually biologically reasonable. And finally, present your answer in the appropriate format. Always including your units. If you memorize this sequence, you will maximize your point extraction every single time.
But before you get too comfortable and feel completely safe, consider this one critical question. You might know the math now, but what about the command words deciding your mark band? Here's the scary part. Getting the math perfectly right is totally useless if you misinterpret the specific command words the examiner uses to actually frame the question. It's a silent killer in Biology 9700. So, as you move on to your next explainer in this series, you need to ask yourself, are you truly decoding what the examiner is asking for? Don't skip that step, because honestly, your grade depends on it.